Have you noticed how abnormally hot it is this year? It's not just your imagination. According to the latest release by the World Meteorological Organization, there's an 80% chance in the next 5 years that new high temperature records will be set again. In other words, it could get even hotter. Some airport runways have cracked from the heat. Even the Eiffel Tower bent out of shape by 20 centimeters due to the extreme temperatures. And in the Arctic, the warming rate is 3.5 times the global average. But just as we begin to fear Earth turning into a second Venus, a mind-bending scientific fact emerges. We are currently living in a long, drawn-out ice age. Specifically, a relatively warm interglacial period. So when will the next glacial period arrive? To find the answer, we must throw you back 1 million years into Earth's past to feel the pulse of its climate and uncover the clues it holds. Here you will witness a magnificent and decisive era, one that shaped the future of life on Earth and left behind the most thrilling traces. This was the last ice age. This exploration will allow you to personally experience the extreme environments that life on Earth endured. Over 100,000 years ago, many ecosystems across our planet were reshaped by vast ice sheets, piercing polar winds and barren landscapes. This was a frigid glacial period, with cold lasting for thousands of years. And as this period came to an end, many iconic species mysteriously vanished. To this day, the cause remains a mystery. What you're experiencing now is not Earth's first ice age. In fact, Earth has gone through 5 in total. So, what do they all have in common? What we call an ice age is a prolonged period of global cold and scarcity, typically lasting millions, even tens of millions of years. This results in much of Earth's surface being covered by ice sheets and glaciers. This is what we commonly refer to as the last ice age. It began around 2.6 million years ago, right at the start of the Pleistocene epoch, and you might be surprised to know we are still living in it today. Every ice age consists of 2 phases, a cold glacial period and a warmer interglacial period. In fact, the era we're in right now is the most recent interglacial. It has already lasted for about 11,000 years. So when people mention the last ice age, they're usually referring to the Würm glaciation, a period that occurred just before our current interglacial. The Würm glaciation began around 115,000 years ago and lasted until about 11,700 years ago. Here's another surprising fact. During that glaciation, the global average temperature was only about 6 degrees Celsius lower than today. Yet even that seemingly small single-digit difference had a dramatic effect on the global climate. A 6-degree drop in global temperature means a tremendous loss of heat from the oceans, the land, and the atmosphere. During the Würm glaciation, most of Europe and North America were covered by 2 enormous ice sheets, the Laurentide ice sheet and the Fennoscandian ice sheet. Much of the Earth's accessible water was locked up in these icy masses, causing global sea levels to fall dramatically. The land, meanwhile, was mostly barren, covered in tundra vegetation and dry grasslands. But what triggered Earth to plunge into such extreme and frigid conditions? No single factor can fully explain it. However, by analyzing the orbital patterns of our planet at the time, scientists began to piece together the puzzle. In the last century, a Serbian scientist named Milankovitch proposed a revolutionary hypothesis that long-term changes in Earth's position relative to the Sun are a major driver of climate shifts, especially glacial periods. He focused on 3 orbital changes that affect how much solar radiation reaches Earth. These came to be known as the Milankovitch cycles. The first is orbital eccentricity, which becomes more pronounced when Earth's orbit is pulled more strongly by the gravity of massive planets like Jupiter and Saturn, causing Earth's path around the Sun to stretch into a more elliptical shape. This orbital cycle, known as eccentricity, spans approximately 100,000 years. When Earth's orbit becomes more elliptical, the seasonal changes become much more dramatic. Summers stretch longer than winters. During such a time, Earth reaches its farthest point from the Sun, called aphelion, around July. At that distance, solar radiation in July can be about 23% less than what Earth receives in January. This shift causes winters to become warmer and shorter, while summers become cooler and longer. The second factor in the Milankovitch cycles is axial tilt, also called obliquity, the angle of Earth's rotation axis. The more the Earth tilts, the more extreme the seasons become. This axial tilt fluctuates on a cycle of about 41,000 years. When the tilt is smaller, seasonal contrasts weaken. Summers are too mild to fully melt winter snowfall. Over time, snow and ice begin to accumulate, a slow, steady trigger for the onset of an ice age. The third factor is axial precession, the wobble of Earth's rotation axis. This wobble is caused by the gravitational influence of the Sun and the Moon. Because Earth isn't a perfect sphere, its equator bulges outward. This irregular shape causes the axis to slowly wobble as it rotates. Precession completes a full cycle roughly every 26,000 years, altering the seasonal contrast further, making seasons either more extreme or more mild, depending on timing. Together, these three cycles, eccentricity, obliquity, and precession, combine to drive Earth's long-term climate behavior. They're remarkably reliable in predicting the timing of glacial periods. However, there are also shorter-term factors that can amplify or soften the effects of these cycles. During the worm glaciation, for example, scientists have identified abrupt climate fluctuations. These include sudden warming episodes, known as Donskard-Ushgar events, and rapid cooling events called Heinrich events. Which brings us to the next crucial question. How did life on Earth at the time survive, and even thrive, under such extreme conditions? What do those creatures look like, and how did they adapt to their shifting world? As we mentioned earlier, the worm glaciation mostly took place during the Pleistocene epoch, which began about 2.6 million years ago and ended around 11,700 years ago. The Ice Age was the age of Megafauna, and mega is no exaggeration. Some of these animals weighed up to 4,500 kilograms. But why was everything in the Ice Age so gigantic? There are several theories, and one of the most cited is Bergmann's rule. This principle observes that warm-blooded animals, especially mammals, tend to grow larger in colder climates. The reason? A larger body has a smaller surface area relative to its volume, which means it retains heat more effectively and loses it more slowly. That might help explain why so many massive and awe-inspiring species emerged and thrived during the Ice Age. Gigantic size was an evolutionary advantage, but it wasn't the only strategy. The remarkable diversity of Ice Age creatures shows there was more than one way to survive. Let's begin with perhaps the most iconic of them all, the woolly mammoth. For many of us, the mammoth is the ultimate symbol of the Ice Age. A towering, majestic figure slowly making its way through deep snow, seemingly unfazed by the bitter cold. But the reality is a bit more grounded. In fact, mammoths weren't much taller than today's African elephants. Measurements from fossilized bones suggest they stood around 3.5 meters at the shoulder, while some modern male African elephants can reach 4 meters. Though similar in height, mammoths were built differently. They wore a warm, double-layered coat, a dense underfur beneath a longer, coarser outer layer. Their bodies were longer, their legs shorter, a design that likely helped them graze without needing to bend too far. They also carried a thick insulating layer of fat, up to 9 centimeters deep, to shield them from the frigid temperatures. And unlike modern elephants, mammoths had small, fur-covered ears to minimize heat loss. Humanity has even made attempts to bring the mammoth back through genetic engineering. But despite our efforts, mammoths eventually went extinct. However, they didn't all vanish overnight. On a remote island called Wrangel Island, a small population of woolly mammoths survived. On Wrangel Island, isolated from the mainland, a group of around 500 to 1,000 mammoths lived on for thousands of years after their relatives had vanished. They survived until roughly 4,000 years ago. a full 1,000 years after the Great Pyramid of Giza was built. Yes, you heard that correctly. Now let's turn to a much stranger creature, the glyptodon. Its name means carved tooth, referring to the animal's wide, grooved teeth, perfectly designed to grind tough, fibrous vegetation. These were heavy, lumbering creatures, weighing up to 2 tons, roaming across the Americas on legs as thick and sturdy as pillars. Their bodies were encased in an enormous, dome-shaped shell, resembling a giant tortoise, and they looked like ancient, overgrown armadillos. But unlike armadillos, glyptodons couldn't roll into a ball. Looking at them, you'd think they were slow and awkward, but recent studies suggest otherwise. Evidence indicates that glyptodons shifted much of their weight onto their hind legs, and may have even been able to stand upright. Imagine that for a moment. A 2-ton armored beast rising onto its hind legs, swinging its massive, club-like tail either to defend itself or perhaps to reach higher foliage. They were far more capable and dangerous than they appeared. The next creature might surprise you because their modern relatives still exist today. But what we see now is only a faint echo of what once roamed the Earth. Just the tip of the iceberg. In the Late-Pleistocene, sloths came in a stunning variety. 4 families, 27 genera, and an unknown number of species. They were excellent dispersers, roaming vast areas across North and South America. And over time, they grew massive. By the Late Pleistocene, evolution had sculpted a remarkable group called ground sloths. One of the most astonishing among them was the Megatherium, a creature as tall as a giraffe and as heavy as an elephant. The earliest known sloth fossil belongs to the genus Mylodon, with an estimated weight of up to 3,800 kilograms. Compared to their ancestors, modern sloths are like tiny cottages sitting beside ancient skyscrapers. And considering the weight of these ground sloths, some of these ground sloths weighed between 800 and 1,200 kilograms. Even more astonishing is their behavior. Fossil evidence suggests some species burrowed underground. This gives us a glimpse into the harsh survival pressures they once endured. Why would such massive creatures dig? Some scientists believe they sought shelter from the cold, or from extreme heat. Others suggest it was to hide from predators. And that raises a chilling question. What kind of predator would dare challenge a creature that size? Most likely it was the saber-toothed cats or the giant short-faced bears. Formidable predators in their own right. When you reflect on these massive and resilient creatures, surviving harsh climates, battling enormous predators and constantly adapting, you start to hope maybe they endured. Maybe they used their instincts to carry on into the next geological age. But that is not what happened. By the end of the Pleistocene, they vanished, almost without warning. In Australia and the Americas alone, between 72% and 88% of all large species went extinct. How could such a massive die-off occur? This question has sparked fierce scientific debate for nearly a century. Some researchers believe natural climate change was to blame. As the interglacial period began, sea levels rose, land bridges were submerged, and vast ice sheets melted, cutting off essential migration routes and transforming entire ecosystems. But this theory has holes. After all, the woolly mammoths on Wrangel Island survived long after these global shifts. So, what else could explain this mystery? In the 1960s, a bold new theory emerged, one that leads us to a more unsettling possibility: humans. And with that, your journey reaches a pivotal moment in prehistory. For the first time, you'll come face to face with the species that would forever change the fate of this planet. Us. Homo sapiens emerged about 300,000 years ago. They began their journey in Africa, and over time, migrated outward, reaching distant corners of the world. That means humans were very much alive throughout the Pleistocene. They didn't just observe the megafauna, they lived among them. Humans shared the land with all these magnificent Ice Age creatures. And because of this, paleontologists began to ask a troubling question. Were we responsible for the extinction of the megafauna? Could it be true? Could humans, armed with only primitive tools, have actually brought down towering mammoths or massive ground sloths? While Homo sapiens emerged around 300,000 years ago, it wasn't until the late Paleolithic, about 50,000 years ago, that our species experienced rapid cultural development. Hunting and gathering practices reached their peak. We began crafting more sophisticated tools, decorating ourselves with pendants, and engaging in symbolic expression like cave paintings. These were not just pictures, they were how early humans made sense of the world. And some of them still exist to this day. This period saw an explosion in technological advancement. Tool-making techniques evolved rapidly, and with them, our ability to hunt became far more effective. One person alone couldn't take down a mammoth, but a group of hunters armed with sharp spears capable of being thrown up to 40 meters could tip the scales. One of the most skilled and organized groups was the Clovis people. They are believed to be ancestors of today's Native Americans, and they crafted a very specific kind of weapon, the Clovis point, a fluted stone spearhead perfectly shaped for big game hunting. Here's where things get controversial. Only a few thousand years after the Clovis culture appeared in North America, many large mammal species vanished. Was it coincidence? Or did their hunting practices trigger an ecological collapse? In fact, a recent study took a closer look at the remains of the only known Clovis individual, a child buried in Montana, known as the Anzick child. Genetic and dietary analysis revealed that mammoth meat accounted for roughly 40% of the protein in the child's mother's diet, which means this child, however innocent, may have belonged to a society that played a real role in the extinction of the megafauna. All of this makes us wonder, what might humans do next? And frankly, the thought is a bit unsettling. Take Australia, for example. A strikingly similar story played out there. Not long after humans arrived, about 85% of Australia's large animal species disappeared. Paleontologists turned to spores in the soil to track megafauna populations over time. And what they found was staggering. Within just 4,000 years of human settlement, those populations collapsed. Yes, environmental changes were happening too, but the arrival of humans may have been the final straw, and Australia isn't the only place where humanity's rise seems to shadow another's fall. In the Late-Pleistocene, one of the greatest mysteries of human history unfolded: the disappearance of the Neanderthals. They vanished around 40,000 years ago. Neanderthals were tough, resilient, and smart. They were among the first human species to survive in the brutal cold of Ice Age Europe. Short and stocky with wide, high-bridged noses to warm and humidify the frigid air. They were physiologically adapted, much like the woolly mammoths they lived alongside. And far from being dim-witted, Neanderthals had a rich and complex culture. So, what happened? How did such a capable species disappear? You probably already suspect the answer. We may have had something to do with it. Some scientists believe Homo sapiens outcompeted the Neanderthals for food and territory. Others suggest we didn't destroy them. We absorbed them. In fact, most people of Eurasian descent carry 1% to 2% Neanderthal DNA, which means they didn't entirely vanish. They live on within us. Still, the idea that Neanderthals were somehow inferior is being dismantled with every new discovery. Their tools, their social structures, their language, all point to a deeply intelligent species. Yes, they may have lost in the evolutionary race, but the image of them as brutish cavemen? That's not only outdated, it's completely unjust. The last ice age brought more than just cold and glaciers. It brought with it a wave of transformations that shaped everything we are today. The Ice Age forever changed the course of Earth's history. And that's exactly what you've witnessed on this journey. Though the era was filled with cold, chaos, and uncertainty, many species thrived. They adapted, surviving through glacial surges and warmer interglacial lulls. As your thoughts drift back from the Ice Age and return to the present, you may feel a deep sense of awe at the wild diversity of life from that time. Yes, most of those creatures are gone now, fossils of a forgotten world, but their bones, their burrows, their burial sites still speak. They whisper of a world that once was, where humans lived alongside mammoths and saber-toothed cats, and even shared the Earth with our closest evolutionary cousins. It was a time of raw coexistence in a landscape both untamed and unforgiving. But here's a question that lingers. Could it all happen again? The unsettling truth is, we are still living in an ice age. We're simply in a warm intermission. So, is the next glacial period already on the horizon? You may recall the Heinrich events, episodes that occur roughly every 10,000 years and trigger abrupt drops in temperature. These events are set off when massive chunks of ice break off from glaciers and flood into the oceans. And according to recent data, before each Heinrich event, the oceans warm. That warming destabilizes the ice sheets, and today we're seeing those very signs. Ocean temperatures are rising. Could this be a warning that another Heinrich event is coming? If so, it could plunge us into another period of cooling. Perhaps even usher in a new ice age. So, when will the next ice age begin? Well, maybe the answer to that question no longer lies solely in the stars or in the tilt of the Earth's orbit. Maybe the timeline is now in our hands. Because while we worry about ice returning, human-driven warming, like an invisible force, may have already shifted the trajectory. If a new ice age does come, which species will survive? And will we be among them? In a world once again ruled by ice and snow, will we adapt and thrive? Or will we be the ones left behind, replaced by creatures more suited to the cold? It makes you wonder, in the distant future, what will Earth look like? And more importantly, who or what will call it home?